I will show you the numerical method using a app on my mobile phone to evaluate the limits of the function sin x over x at the value x equals 0. You will notice for this function sin x over x, if x is 0, you cannot have a number divided by 0, so you will get undefined. So there is a question, what happens when x approaches 0? What happens? As it gets closer, as x gets closer and closer to 0, we would like to know what happens to this function. But at the point x is equal to 0, the value is undefined. But before it gets to 0, we want to see what is the behavior of sin x over x using numerical methods to find out. Basically, what I will be doing is I will be plugging in numbers for x as x gets closer and closer to 0. Let us pick a few values and see what happens to this function. A lot of colors to choose from, as you can see, and also a lot of numbers of x to choose from. So let this column be x and this column be sin x over x. And we'll do a small table right here. Let's do a small table right here. We'll choose some values which are very close to 0 and see how this function behaves. Minus 0.5, minus 0.1, minus 0.01, the actual 0, plus 0.01, plus 0.1, and plus 0.5. Basically, we have 0 here, plus minus 0.01, plus minus 0.1, and plus minus 0.5. Wrong color. Should have been orange. Sorry. Okay, now the interesting thing is I'm going to be using my calculator and you can see how it works. I'll do it real time for you. So the function would be sine x over x. So let's choose sine x, where x is minus 0.5. So minus 0.5 divided by minus 0.5, same value. So let me write it down. The value would be 0.9588510. 1, 2, 3, 4, 5, 6, 7. Let's do 8 digits. 5107. That's good enough for our illustration purposes. The next number is minus 0.1. You go up here, go in here, minus 0.1, and below here, get out, go down, minus 0.1, 0.1, it didn't work, minus 0.1 here and minus 0.1 here would give me 0.998333416. Let me write it down. 0.998333416. The next one would be minus 0.01. So minus 0.01. And below here, minus 0.01. Okay, the value would be 0.99983333. Now at 0, the value is undefined because any value over 0 is undefined. So let me write it in a different color, undefined. Moving on, let's do plus 0.01. So the number would be, the result would be 0.9999833. Notice something interesting coming along here? Let's try this one. Do you think it'll be the same as that one? Do you think the result here, where you plug in x equals 0.01, would be the same result as if you plug in x equals minus 0.1 into the function, this function? Let's find out. Be very interesting. So 0.1, plug in 0.1. 0.1, 0.998333416. What's happening? We're getting the same number. This number and this number is the same. I'll explain to you why later on. Let's finish up the last point. The last x value to evaluate would be 0.5. And the value is 0.9588510. This number of the function sine x over x is the same as this number. So I'll explain to you why, but basically just to tell you a little bit ahead of time, it's because sine x over x is an even function. Okay, I can show you how to use a calculator like this on your mobile phone in a future lesson also. Okay, I'm gonna take this out. there is a concept of approaching zero from the negative and approaching zero from the positive. If you take a look at the graph along here, where this is y, which is sine x over x, and this is x, and this is 0, when you are when x is here, x0, it can approach 0 from the right hand side, and if x is here, it can approach, let's call this x1, 0 from the left hand side. In this first case, is actually approaching 0. The x value, which is this value, is approaching 0 from a larger number. Here's a larger number, 0.5, 0.1, 0.01, and it gets smaller and smaller, and it approaches 0. And for the other case, x1, where x1 is a negative number, right here, x1 is a negative number, x1 can approach 0 from the smaller side of 0, from the negative side, minus 0.5, minus 0.1, minus 0.01. So what can we infer or logically deduce from this set of numbers? What we can logically deduce is that at 0, x is undefined, but as x, the value of x approaches 0 from either side, it seems like, look at the pattern here, 0.9588, 0.9983, 0.9999. Do you see that it approaches a number, and that number seems to be 1? Same here, 0.5. The value of the function is 0.9588, and then the next value as we get closer from the positive side is 0.99833, and then finally 0.9999. If we take an even smaller number like 0.0001, the number of nines would actually be increased along this, in this number. So what is the interesting thing which is happening looking at this set of numbers which we have here is that as x approaches 0 from the positive side, which is from here, 0.5, 0.1, 0.01, we see that the function sine x over x seems to approach 1, 0.9588, 0.9983, 0.9999. It seems to approach 1. And when the value of x tends towards 0 from the negative side, it seems that the value of the function sine x over x approaches 1 also, 0.9588, 0.9983, 0.9999. It approaches 0. But at the point 0, it's actually undefined. So it can approach 0 but never get there. I can draw So this is what I can draw with this table of data which I have. I can conclude that it approaches plus 1 here, which is 0.999 here and 0.99 here. Whether I approach 0 from a bigger value or from a smaller value, I will still get closer and closer to 1, but I can never get 1. And I denote that by a circle with nothing inside it. If I want to say that it actually touches 1, what I'll do is I can say this with a filled in circle, or just write this. It would be the same. I can write this, all this would be the same. I would like to know what happens. Does it cross the x-axis in any way? Does the value sine x over x cross the x value in any way? The way to do this is to continue on some more values. Use my orange again. I used my red by mistake. So I'm gonna do this, pi and minus pi. So I'm gonna evaluate what happens when x is equal to pi. So sine pi over pi is, sine pi is 0. We know that because, let me draw a small sine function, right? This is 0, pi, and 2 pi. So sine pi is 0. So it's sine 0 divided by pi. Any number divided by any number 0 divided by any number is 0. Likewise, for sine minus pi over minus pi, sine of minus pi is minus pi here, also 0. So 0 over pi is also 0. So very interestingly, we can now say that at the point pi, at the point x equals pi, the value of y is 0, and the point x equals minus pi, the value of y is also 0. So we can actually extend this curve down to here, and it actually touches and crosses, and then we know that the value of this point is pi, and this point is minus pi. Next lesson, I will show you what happens to this function sine x over x below here. Something interesting happens, and we will do another similar analysis for when x tends towards positive infinity going this direction, and when x tends towards negative infinity going this direction. See you next time.